हमने सारी की सारी फोर्सेस को डिस्कस करना शुरू किया कि फोर्सेस कौन कौन सी होती हैं. yesterday we discussed about drag force, friction, net force and everything. Now आज हमने डिस्कस करना है नॉर्मल कॉन्टैक्ट फोर्स. नॉर्मल कॉन्टैक्ट force. Now if we put an object on a surface like this, तो ये ऑब्जेक्ट अपने वेट की वजह से exerts a downward force on the surface. And what should this surface do in return according to Newton's third law? It should exert an equal and opposite force, and this force is called the reaction force. So in this case, reaction force will be equal to mg. Now, what if there is an extra force acting on the object? Okay, this is the same object, and I'm exerting an extra force on the top of the object. Now, this is force F. In this case, what do you think? The contact between the object and the surface will become stronger or weaker? If there is this force F, which is trying to put the object or make the object go into the surface, what do you think? What do you think? It will be enhancing the contact or it will be weakening the contact? Now, if you pay attention, you will think that force is trying to push the object into the surface. So that is why the reaction force in this case will be mg plus F. Similarly, if there is a force acting in opposite direction, for example, this is the case, and the force is acting upward. In this case, the normal contact force will be mg minus F. Now, what if the object is on an inclined plane? Mg is acting downward like this. This surface is at an angle theta to the horizontal. So this force will have a component of weight acting perpendicular to the surface into the surface and a component which is along the surface. Now, this angle is theta as well. So what do you think, what will be this component? The one that is opposite to the angle. Okay, so this one will be, because this is mg. This is weight mg. So this will be mg sine theta, and this one will be mg cos theta. So one of them is responsible for the object to come down along the slope. Which one it will be? Mg cos theta or mg sine theta? If you pay attention, you find it is mg sine theta, which is acting down the slope, and reaction force will be equal to what in this case? In this case, reaction force will be mg cos theta. So reaction force keeps on changing because of the orientation of the object. Now, let's move forward. Another object where the net forces are very important are pulleys. Now, this is a pulley. Pulleys are used to change the direction of tension. Pulleys help us to change the direction of tension. Uh, Listen, there is this luggage on a horizontal surface. You are standing here. Now you want to lift the object up. Thing is that to lift the object up, you have to exert an upward force. But you cannot. You are a person, you are standing on ground. You have to lift this object to this height over there. You have to make the object go to that height. Now, how can you do that? What you do is you use a pulley, you attach a rope to the pulley, and the other end comes and here is attached to the object. You make the rope go along the pulley and make it come down. Okay. So what you do is you now exert force in this direction. And that will help the object to come up. Okay. So pulleys do what? Pulleys help you to change the direction of tension. They can be very useful. If you have to take water out of a well, either you have to bow down on the top of the well, which is very dangerous, and it is very tiring as well if you have to pull the water up. So what you do is you use a pulley like that on the top of a well. You lower the bucket into the well, and then you just actually you are pulling the rope downward, and pulleys helping you to fetch the water or bring the water up. So pulleys help you to change the direction of force. Now, this is a pulley. On this side, you have a load, say, M1. On this side, you have a load, say, M2. And M1 is heavier than M2. M1 is what? Heavier than M2. This is a pulley. Frictionless pulley. What did we learn about the tension yesterday? That the tension is always acting opposite to the direction, opposite from the surface of the object it is attached to, along the rope. So when we focus on this one, we think that the tension is acting this way. This will be the direction of tension. So there will be a weight acting downward. Weight will be M2G. What will be happening in the other case? Weight will be acting downward. It will be M1G. And in this case, the tension will be acting upward. Now, let me know, do you understand what will happen if I let go the object? Which object should go in what direction? This is ground. So which object should come down? Which object should go up?
होगी टी से.
If M1 is coming down and M2 is going up, then M1G has to be more than tension. That's why M1 is accelerating downward. And what will be the competition between P and M2G? P will be heavier, P will be more than M2G. That's why M2 will accelerate upwards. This one will accelerate upward, and this one will accelerate downward. Now let's make equations for them. M1. Do you remember the force second law equation? If there is an object like this, forward force F, backward force Fr, what was F minus Fr equals to? F minus Fr equals to Ma. So M1G minus T equals to M1A. Now, what will the equation in this case? Because the object is accelerating upward, it means T is bigger than M2G. So T minus M2G equals to M2A. We are not considering directions as well. We are not giving any account of direction over here. So now we have two equations. Let's see if anyone can fetch me an expression for A in terms of M1, M2, and G. Can anyone find an expression for A in terms of M1, M2, and G? Okay, I gave you enough time. All you had to do was make A subject of formula in an expression which was completely independent of T. Because only then, look, I asked you to make a formula of A which had no T. This is how I did it. From the first equation, I made T the subject of formula. It became M1G minus M1A. In the second equation, T became M2G plus M2A. Because both are equal to the same T, M1G minus M1G minus M1A equals to M2G plus M2A. I shifted all the terms that have A on one side, all the terms that are independent of A on the other side, and made A the subject of formula. And this is how I did it. So okay, let's move on. What is pressure? Pressure equals to force over area. If somebody asks you to define pressure, you said it is pressure is force over area. Unit for force is newtons, unit for area is meter square. So the unit for pressure will be Newton per meter square or pascals. Now, this is how you can measure pressure when one solid object is exerting force on another solid object, or a fluid exerting force on a solid object, because in that case, the force will be acting on a specific area. But we cannot find out how much pressure is exerted by fluid or gas using this formula. Actually, it can be used, but the problem will be to know exactly how much force liquid is exerting is difficult. So we have to come up with a different approach for that. So let's start. This is a container. This container has a base like this. The area of the base is A. Now, this container is filled to this height with a liquid. This is height of liquid. Now, density of liquid is rho. So pressure equals to force over area. Force in this case will be weight. Weight equals to mass times gravitational field strength. Mass will be equal to density multiplied by volume, and volume equals to base area into height. Listen, pay attention. I needed to calculate pressure. Pressure required force and area. Okay, I want to know how much force is exerted by the liquid on the base of the container. So we figured out that the force that liquid exerts on the base will be equal to weight. Okay, then what weight is equal to? Mass into gravitational field strength. I know the value of gravitational field strength. It is 9.81, but I don't know what mass is. How can I find mass? When I asked myself, I thought of the formula that mass equals to density times volume. Okay, I know the density. Density is given as rho, but how can I find volume? Now, volume is base area into height. So now we will be doing reverse engineering over here. Volume equals to area into height. Mass equals to area into height into density. weight equals to area into height into density into gravitational field strength, which is also equals to force. So pressure equals to A H rho G over A. A and A get cancelled. Pressure equals to rho G H. And this is how we can find out the formula for pressure of fluid. This is the formula for pressure of fluid. Now, what pressure depends on? Pressure depends on density of the fluid, it depends on gravitational field strength, and it depends on depth of the object in the fluid or depth of the object in the fluid. Now, if this is a liquid or fluid, this is point A, this is point B. This is the base of the container. This is height of B, and this is height of A. Okay. Which point will be under more pressure than the other? Now, apparently, when we look at the formula, it is rho GH. It seems like if there is more H, there should be more pressure. So it apparently looks like A should be having more pressure, but answer is B. B has more pressure. Why? Why B has more pressure? Answer is the height actually means in the formula pressure equals to rho GH. H is height of fluid column above the point. So actually, this is the height that we talk about. This will be height of A, not this one. This will be height of B, not this one. That's why B will have a higher column of fluid on the top. So B will have more pressure than A. So the thing that we learned, point. As we go lower into fluid, height of fluid above point increases, hence pressure due to fluid increases as well. Now, this is strange. This is strange. Uh, we are leading towards a thing which is known as buoyant force. Just hold on for a second. Okay, excuse me. Now, let's see if we can find it out. This is fluid. This is a solid object. Now, this is surface of fluid. This is a object, solid object. Now, on this object, there will be a pressure acting on the top. Okay, pressure is not a vector quantity. It is always perpendicular to the surface. So whatever the direction of the surface is, it will be acting in the perpendicular direction to that. Now, on the top, the pressure because of the fluid will be like this. On the side walls, so what is happening to the pressure on the sides? So when you see the pressure on the side is gradually increasing. Okay, so these are pressures. And what is happening to the pressure as we go down? Pressure is increasing. Okay. So pressure is increasing and it is again acting perpendicular to the surface inward. So why there will be no net force in any side? Answer is there is no net force because the pressure is increasing equally with equal depth. So at any point, there will be equal pressure on both sides, equal force on both sides. So there will be no net effect. But what do you think about the base? On the base, there will be a pressure acting upward like this. Now, do you think the pressure at the top and the pressure at the bottom are equal? Will they be balancing one another?
Uh,
Just 1 second. Okay. Now, look, as you go down, the pressure is increasing. On the side, there will be no net force, but the pressure at the top and the pressure at the bottom are not equal. So they will not be balancing one another. Not. There is always more pressure at the bottom than at the top of an object because pressure increases with depth, and bottom is always at more depth. This difference of pressure at the top and the bottom of object produces a net upward force. This force is called up thrust. So upthrust is a force that is caused by pressure difference at the top and the bottom of an object. Some people think that it is caused because of the density difference. Actually, that is not true. Pressure difference at the top and the bottom produces upthrust. What is the formula for upthrust? Upthrust equals to volume of fluid displaced multiply by density of fluid multiply by gravitational field strength. Okay, so upthrust equals to volume, density, and gravitational field strength. Okay, confusion? Okay. Now, units, volume must be in meter cube, density must be in kilogram per meter cube, gravitational field strength is in newtons per kg, and upthrust is in newtons. Okay. Why some objects float, some get suspended, and some sink in any fluid. Now, this is a fluid. This is a base. Now, we have three objects here. Question, answer. Following objects have just hold on for a okay, excuse me. Now, these are three identical objects. Following objects have same dimensions, so they all upthrust but different weights. So they all have same upthrust,